All right, hello, beautiful people. Um, Long time no see. Hopefully, some of you will have a chance to watch this video later if you're not already awake and doing some mathematics. I wanted to talk to you today about the two biggest patterns of error I was seeing on your Unit 1 USA test prep assignment, because I know from reading your emails that that's the thing that's kind of most worrying you at this time. I got a question literally 17 minutes ago that I wanted to address about how USA test prep will be graded. Someone's mom wrote to me and was talking about how they were really stressed about a test that they had taken during the extended school closure. There is going to be one test score, the test score for Unit 3B, that won't be simply a replacement grade. But today I want to just talk about Unit 1. For Unit 1, that has the potential in USA Test Prep for being a replacement grade. So, for example, if you had a low test score or a low quiz score during Unit 1, way back in January, at the end of January, I think it was January 23rd, then your score in USA Test Prep could replace one of those low test scores or low quiz scores, whichever one's lower, the quiz or the test. If for some reason, I think this doesn't really apply to anyone, but just in case there's maybe one person who didn't take the Unit 1 test and never had a chance to make it up, then that obviously would fill in that place for the 0. You can take the USA Test Prep assignment as many times as you want. That's true for Unit 1, Unit 2, Unit 3A, and Unit 3B. And you're welcome to use all the resources available. That includes your notes, your practice problems, videos that I've shared, or videos, teaching videos that you find online. If you're curious about finding some videos, you can't find some resources to look at, you can either talk to me and we can talk about it in YouTube or in Schoology, or I can actually lead you to a video that would be helpful and send you a video link of something that I found for you to use. Okay, so hopefully that answers that question. Now let's go into your questions about USA Test Prep. One of the bigger problems that I was seeing was a problem with linear modeling and applications. Essentially, linear models work in two ways in algebra. Sometimes you're given a word problem, and then you have to write an equation or use that equation to find a solution. Or in these two cases from the USA Test Prep assignment, what you see is you're given a situation and you're given an equation, and then you're asked to interpret certain values in that equation in an application, like what they would mean in the real world. We had two problems like that, two questions like that on the Unit 1 USA Test Prep. One about Jorge talking to his friends about a math test, and one about Ted, who was researching the price of tickets and miles traveled through the airline. Both of these kind of things that we talk about a lot in our day-to-day life. Obviously, I can't talk to you specifically about these problems, but I want to talk to you about linear modeling and applications in general, so that you can take what we talk about here and then apply that to further your understanding of the USA Test Prep assignment. Okay, let's see here. Okay. You all know that linear models are always going to be expressed as y equals mx plus b. We've talked about before how y is generally a total or some goal that you're trying to reach. It could be a total price. It could be a total cost of something. Sometimes it could be in a situation where we're asked to say how many hours would someone have to work or have to study and able to reach a certain y value. We also talked about B quite a bit. On a graph, we know this as the y-intercept. In other words, the place where the y unit starts, whereas this might be the place where the y unit ends up or finishes, right? Both of these are what we would call numbers. Some people would call them, this one certainly, a constant number. They're always going to be the same units. If this is dollars, this will be dollars. If this is pesos, it would be pesos. Things like that. In this case, it's always going to be what we would call our initial or starting value. And this, of course, is also going to be a number, our slope. But this number, even though it would be this unit and this unit, this will be something that gets added or subtracted multiple times. So let's say I start a job and the job pays me by the hour. Let's say I work at Wendy's and they're going to pay me by the hour. And I want to know how long it will take me to earn, I don't know, $300 because I want to buy the new Animal Crossing Nintendo Switch console. So I know I want to earn a total of $300. I know that there's a value that's going to happen each time, every hour I work. We'll go with $7 because that in Georgia is about what Wendy's pays. And then we could use X. I'm going to go ahead and put H for hours. You could write 7X if you want. And then we're going to think about what our starting amount is. What amount of money we have, say, in our bank or in our savings. I put a positive because I kind of hope that everyone is starting with some kind of money. Like we're not starting by owing like our mom or our dad or somebody else before we can save up for this money. Let's say $100. Okay. So in this situation, this is our starting value. We have $100 at the start of our job before we begin it. If we worked 0 hours, maybe we decided we didn't like the manager at Wendy's, we didn't want to work there. If we got 0 hours at Wendy's, we would still make $100. Okay, that's part of what that starting value means, is that even if we never start earning money at Wendy's, certainly before we start earning money at Wendy's, we would still have $100. We wouldn't be at our 300 amount. So sad. Okay. But this is the amount that we're going to add each hour we work. Okay. All right. Let's see. Okay. Let's think of another situation. I'm playing Pokemon. Yay. And what I've noticed is that I need to fight a certain amount of battles to level up my Pokemon. Right now, my Pokemon has 1,000 experience points. Okay. And then I start to notice this happening each time. And this is kind of the question you'd see on the USA Test Prep. They'll give you a situation. We are catching Pokemon. And then they'll say, and our situation catching Pokemon is represented by this equation. Y equals 100x plus 1,000. And what we'll see is, then they'll say to us, what does the number 1,000 represent? And we'd have to know that's our starting value. If we stopped training our Pokemon right now, that's the value it would have before we fight another battle or a single battle. That is the value when X is 0. okay? And then this value, 100, represents something that'll happen again and again and again. And I've noticed each battle this happens. So each battle, that means I learn or gain 100 experience points each time I battle. Okay. All right, I'm going to come back to that if maybe there's more questions. If not, we'll just stick with this understanding that this value, the constant by itself, is a starting or initial value. It's what would be the result of working, of studying, of playing, of some activity modeled by a linear equation. This would be the result if x were 0. If we never went to work, if we never played a game of, if we never fought a battle in a Pokemon game, this would be the base, okay? The base or starting initial amount. And then this, M, or slope, also called rate of change, refers to what would happen over and over and over. Sort of like if we studied for an hour, how much our points would go up. If we went to work, how much our bank account would go up. If we battled a Pokemon, how much our points would go up. Okay. The next thing I want to draw your attention to is this set of problems here. This was one of the big questions people were having. I think the correct rate was maybe 40% earned on this first question, and then about a 47% on this second question. So I know there was some confusion about that. All right, beautiful people. I have noticed that my comments are turned off. Let me see if I can manage to fix that. Live chat. Enable live chat. Yay. Aw, shucks. Heavens. All right, beautiful people. I apologize. It seems like it won't let me do a change. Sorry. This is my first foray into live streaming. So what I'll do is I'll simply talk about rational numbers versus irrational numbers, and then you can leave me comments in Schoology and I can reply back. If not, when I talk to you again on Thursday, I'll answer any questions that you've sent to me about this video on Schoology, and I will figure out, I promise, by next Thursday how to enable comments. All right, so the number system is something that you've talked about in middle school, but again, it's something that we talk about pretty quickly and then we move on as teachers because we want to get into kind of the nitty-gritty of doing actual mathematics. But the number system and its rules are kind of the physics of mathematics. They're the reason everything works. So one of the underpinnings of that is irrational numbers versus rational numbers. And we are interested in talking about those with their under certain operations. In Fancy Math Talk, we talk about whether those things are opened or closed. What I want you to understand here is that there are rules that govern what happens to irrational plus irrational, and rational plus rational, as well as irrational plus rational. And you can simply Google those rules. You can take a look at your notes. One of the things that we learned for sure is that irrational numbers under addition and subtraction are not always going to generate an irrational number. They will sometimes generate a rational number, whereas rational plus rational will always result in a rational number. And both the assessments on USA Test Prep ask for what happens when you're adding things together. I can't talk to you specifically about that because I don't want to be a cheater, but I will talk to you about multiplication, and then you can use our conversation about multiplying rational and irrational numbers to help you understand what to change your answers to on USA Test Prep. Okay, so let's go ahead and talk about rational and irrational numbers. First of all, rational numbers, and we've talked about this a lot, and hopefully this will help it come back to you. Rational numbers have the word ratio in them. So I'm sure you've heard since 6th grade, a ratio means it can be written as a fraction or a proportion, something like that. Rational numbers can look a couple of different ways. They can look like a whole number. They can look like a fraction. They can look like a decimal that ends, even if I added some more, like, oh, it ends 0.222. That's the end. Or it can be what we would call a repeating decimal, something like this. And that would mean this is going to keep going 1, 2, 1, 2 over and over and over. If you have a number that's a whole number or an integer, if you have a number you can express as a fraction, if you have a number that has a decimal that eventually ends, like there's not a bunch of numbers after this, it's just 0.22. Or for example, something like 22 cents, that's a rational number. Or it's a decimal that repeats, that's rational. Even though this doesn't look like a fraction, if we wanted to, we could write it as a fraction. Again, even though this doesn't look like a fraction, or 0.22 doesn't look like a fraction, we could say I have 22 cents out of 100 cents, or I have 22 cents out of $1. This too, we could write as a fraction. Okay, so we can write all of these numbers as fractions, and that's what makes them rational, even though they can look a bunch of different ways. On the other hand, irrational numbers, like if you're irresponsible or something's irrelevant, it's not responsible, it's not relevant. Irrational means that something cannot be written as a ratio. And there's only two ways that this can look. It looks like a decimal that keeps repeating without a pattern. And on your calculator, it would simply round up. Like if this number were 7, your calculator can only show so many digits, so it would simply round it up like this. But if you actually went and looked at the value, it would show you ... It would show you that the value went on forever. The other way it can look, irrational numbers, is something like this. We also know about pi, the very famous irrational number that's written as a never-ending decimal. This too is written as a never-ending decimal. If you put the square root of 7 into your calculator, it will give you a never-ending decimal. And all these irrational numbers are decimals that never end and don't have a pattern. Because again, there can be a decimal that never ends, like 0.333333, but that has a pattern of repeating 3 over and over and can be written as the fraction 1/3. All these other numbers can't be written as a fraction. So that's the theory behind rational and irrational. Let's take a look at a question similar to this. If x equals 3/4 and y equals 8, consider the sum of x and y. Which statement describes the sum of x and y? So let's write a question that says, if x equals the square root of 2 and y equals the square root of 4, which statement, let's see if I can't remember the wording, which statement describes the sum of x and y? Describes, and again, instead of sum, which means adding, so you would try to add those, and you can add them by hand, or you can even add them in your calculator and see what happens. Which statement describes the, let's not do sum, let's do multiplication, which we would say is the product of x and y. So that means what I'm going to do is I'm going to multiply the square root of 2 times the square root of 4. I have my friendly calculator. Sometimes it helps to use technology. All right, second quit. Let me clear off my history. All right, so I have the square root of 2 times the square root of 4. And see how it gives me this long decimal? All right. Now, if we remember our rules for doing that by hand, we would say the square root of 8, because what you do is you multiply 2 times 4, and you keep their product underneath the radical. We've also talked about simplifying this, and this would simplify to, because we would write this as the square root of 2 times 4, and this is the square root of 4 is the whole number 2, square root of 2. We would rewrite it as 2 square root of 2. And again, we talked about how the EOC will often require you to multiply by hand, but of course you don't have to do an EOC, so our calculator skills and our knowledge will be sufficient here. When we type this into our calculator, we got the square root of 8, also known as 2 square root of 2, and it's this long decimal, 2.828427125. And it's kind of hard to see if that is, it looks like, oh, it terminates. However, you'll notice it's really long. It's as long as a calculator can make a number, and we don't see a pattern. It's like we have 828427125. Now, if this went 828427828, we might suspect that there was a pattern, but it doesn't. It has a set of 3 more numbers. And so we can say that this is a non-repeating, never-ending decimal, and thus we have an irrational number. Let's take a look at another example. Okay, if x equals 10 and y equals 10, which statement describes the product, and again, we're going to do product, although your USA test prep asks for sum, of X and Y. Now, if we, again, use our calculator, we can kind of take a look at what is the square root of 10. And again, we see 316227766. Again, we see a long decimal that's as long as the calculator can make a decimal. And we don't see a pattern. It goes to sixes, 6, but there's no line over it, so that doesn't imply it's 6, 6, 6, 6, 6 is forever. And it didn't go 1, 6 at the end, so we can't hope that it's repeating 1, 6, 2, 2, 7, 7, 1, 6, 2, 2, 7, 7, or something like that. So the square root of 10 we can see as an irrational number. So what we have here is this: we're multiplying an irrational number and an irrational number. Now, if we multiply the square root of 10, and we can just say times, it'll keep our answer in there. The square root of 10, we get 10, okay? In part because if we did this by hand, we would get 10 times 10, all under the radical. That would equal the square root of 100. And of course, 100 is a perfect square. That means it has a square root. And the square root of 100 is 10. So here we have an example of an irrational number and an irrational number being rational. Oh, sorry, that's my pug. Hey, Albie. Albie. Albie, what's wrong? And on this side, when we have the square root of 2, if we put square root of 2 in our calculator, we can see that the square root of 2 is an irrational number, a non-repeating, never-ending decimal. And then, of course, the square root of 4, because 4 is a perfect square, is 2. So on this side, we had an irrational number times a rational number equaling an irrational value. So let's see if we can think of a rational. So here we had rational and irrational, because we want to kind of make up some rules, right? What we've learned is this so far. Example 1, we had irrational plus rational equals irrational. Then on the back, we had irrational plus irrational equals rational. And now let's try and see if we can get an irrational, not plus, times, JK, times a rational number to be, instead of irrational, rational. Let's see. Let's think of an irrational number. Aha! Irrational number. Let's do square root of 7. If you're not sure if that's an irrational number, notice too it's not a perfect square, right? Our list of perfect squares are 4, then 9. So it skips right over 7. So that means it's not a perfect square. And because it's not a perfect square, it means it doesn't have a rational root. So this is an irrational number. You can also type it in your calculator. You'll notice again, it's a non-repeating, never-ending decimal. And then one of my favorite rational numbers, 0. Okay. Square root of 7 times 0 is 0. Okay. Let's think. So that suggests that that would work. Yay. Irrational. And then let's check if we can get an irrational times an irrational instead of being rational to be irrational. Let's check it out. All right. We'll stick with 7. Okay, square root of 7. We know it's not rational because, again, it's not a perfect square. And then let's do times the square root of 5. Both of those are irrational numbers. They're both not perfect squares. And again, if we tried it out in our calculator, we'd see they're not perfect squares and they're not rational numbers. Okay, so the square root of 7 times the square root of 35 is the square root of 7 times 5, which is the square root of 35. Alrighty, let's use our beautiful technology, square root of 35. Again, we get another long decimal that has no pattern. Again, irrational number. We could also remember how we simplified radicals in Unit 1. We learned to simplify radicals in Unit 1 and often during gold time. And we always start with the list of perfect squares, 1, 4, 9, 16, 25, 36. And we look to simplify those radicals. We try to simplify them by finding a perfect square. And again, this isn't a perfect square, so it won't be a rational number. There's no way to simplify it. So this is an example of an irrational times an irrational being irrational. Now we've tested what happens to rational and irrational numbers when they're multiplied in different combinations. Irrational times rational, irrational times irrational, and how it can be either irrational or rational. And you can also look at your notes or look at some videos online or even Google rules for adding rational and irrational numbers, and I'll just give you a list of rules, and that will help you determine how to answer questions like this. Okay, let me check really quickly my Schoology to see if there are any Schoology messages. I do not see any Schoology emails at this time, so I will see you guys on Thursday. I also promise sincerely to figure out how to add enable comments so that when we do talk next time, we can have more of a conversation. Feel free to message me on Schoology and just try to keep learning. This semester, hopefully, your grades will, not hopefully, your grades will only go up. From whatever you had on March 13th, your grade can only go up. So, for example, if, and we'll talk about this next week, on the assessment for 3B, if that score is lower than your March 13th average, then that grade won't be calculated into your final grade. It won't count. Oh, look, there's my puppy. But if it's higher, it will help your grade go up. Right now, learning should be an opportunity for your scores to increase. Grades shouldn't be used, and I certainly won't use them, as a way to punish you into doing work and staying on task. These are stressful and strange times. So the only thing I hope for all of you is that you continue to learn and that you continue to be motivated to see your grade go up so that everyone has a chance of both passing the class and earning a grade and a GPA that they're happy with. See you next time. Bye, beautiful people.